Hello everyone. So we will be solving the second problem of this LeetCode Weekly 506 contest. The problem is quite interesting. It is a very great problem. Let's try to solve it, right? So the problem goes by the name frequency balance subarray. So you are given an integer nums. Define a frequency balance subarray as follow. What are the conditions for a subarray to be frequency balanced? The subarray should contain only one element. It is frequency balanced. If the subarray contains only a single element, that is all elements are, let's say, 7, then that subarray is balanced. The second condition can be that if the subarray contains at least two elements, then every element with maximum frequency must occur exactly twice as many times as every other distinct value in that subarray, right? You need to return an integer denoting the length of the longest frequency balance subarray. A subarray is a contiguous non-empty sequence of length within an array. The frequency of a length is the number of times it occurs in an array, right? Let's take up this example, right? Uh, let's copy this and let's paste this here, right? Right. So if you look at this example, right? So the possible combination or the possible answer of this subarray was this one. If you take this subarray, right? So the subarray becomes 2, 1, 2, 3, 3, right? So in this case, if you look at the maximum frequency of any element, that is 2, right? 3 came twice, 2 came twice, and 1 came once, right? So this is the number, this is the times, right? So what I'm trying to say is maxi is of 3 is 2, right? So 3 came twice and 1 came only once, right? So 1, if you multiply this by 2, it becomes as many times the maximum number, the number that came maximum times, right? I hope I'm making sense to you. If not, hold it for a minute, right? What I'm trying to say is, see, 1 should come, 1 should come exactly twice of times of 1, times of 1 means what I'm saying trying to 2 into times of 1 should be equal to count of or times of maximum, right? Times of maximum, right? This is a very, like, the language of the problem could have been a bit better, but it is what it is. You have to go with that only, right? So if you look at this now, so this becomes valid, right? Because 1 came once, 2 came twice, which is maximum number of times, and 3 also came twice, which is the maximum number of times. So 1, if you multiply it by 2, it becomes as many times the maximum number of times any number came, right? A bit clumsy, but hold on for a minute or so. You will be familiar with the problem, right? Uh, One more thing the problem said is, if you had only one distinct element, a very important point, right? If you had only one distinct element, right, then uh, it is okay, right? It is okay that, let's say, if you had only 7, 7, 7, 7, 7, 7, so on and so forth until last element, all elements are 7, then this subarray is valid, right? And why is it valid? Because there is only one element, so there is no maxi by 2, right? Let's say maxi was 100, so there is no maxi by 2, means maxi means 100 times a number came, right? There is no other number, so this is a valid sequence, right? So what they try to say is, if you had only one distinct element, then that's okay, you can consider that subarray as a valid length, right? So I hope the problem statement is not exactly clear, but half of the problem is clear, that what can be the possibilities of a frequency balance subarray, right? Let's look at a few test cases. Let's say if all elements were 5, so as we were speaking as of now, that if all elements are same, then that is also a valid valid subarray, right? Because all elements in that subarray is 5, right? So we will consider this whole subarray as a valid one, right? So let's say we had 5, 5, 5, 5, 5. So this count of maximum, right? Count of element 5 is 4, which is maximum number of times, and there is no other element which is 4 times, right? So we will ultimately have this subarray as valid, right? Or a frequency balanced subarray, right? And if you look at one more beautiful test case, it is 1 2 3 4, right? Now this was the problem. This is the part where you might not understand the problem. If you look, the count of 1 is 1, right? Count of 2 is also 1, count of 3 is also 1, and count of 4 is also 1, right? While we were solving this, while I was solving this during the contest, I thought this is also a valid subarray, right? But no, they have explicitly mentioned that if you have an element that is, let's say, count of 1, which was 1, right? And this 1 is the maximum, 1 is the maximum time an element came, right? 2, again, count of 2 is 1. That means 1 is the maximum number of time an element came in that subarray, right? Now they, what they want you to do is, they want you to say that count of that maximum element, right? This plus count of maxi by 2, right? Maxi by 2 is 0, right? So first of all, this can't be a valid sequence, because if you have a odd number, right, then odd number won't be a valid. You can't have a other number which has a frequency of by 2, right? So this is the reason why this case fails, right? Because see, there are 4 elements which give a maxi of 1, right? But there is no element which gives maxi by 2, right? So due to this case, there is no element which follows the second condition, right? The second condition was that the subarray contains, if the subarray contains at least 2 elements, means you can have more than 2 elements, that's okay. Then every other element with maximum frequency must occur exactly twice as many elements as every other distinct value in that subarray. That means the problem wanted you to have at least one element which is maxi by 2, right? They want you that there should be at least an element that is maxi by 2. I hope we are on the same page till now, right? So I hope the rules are clear to you. The rules are very simple. The rules, what are the rules? The rules are, if number of distinct element is equal to 1, then that is valid. That is valid. And the second rule is, if you have distinct greater than 1, right, that means that the other element which you have, right, other element which you have, all other elements which you have should not be equal to count of maxi, right? That means what I'm trying to say is, let's say if you had 2 2 2 3 3 3, right? Tell me one thing, is this whole subarray a valid thing? No, it is not. Why? Because if you see, count of 2 is 3 for the whole subarray, and count of 3 is also 3, right? So the maximum number of time, let me change this number by, not 3, by 4, right? Wait, let me do it quickly. Yeah, what I'm trying to say is, let's number this as 4 4 4, right? So count of 4 is 3, right? So if you look, what is the maximum number of time an element came? That is 3, right? 2 came thrice, 4 came thrice, right? My problem statement asks to you is, really sorry for that, my mic got stopped. Yeah, so what I was trying to say is, if your count 2 is 3, in this case your test case is not that good. Let's take 2 2 2 2, and let's take 10 10 10 10 10, right? So count of 2 is 4, right? And count of 10 is also 4, right? So the maximum number of time an element came was 4, right? That is, 2 is also 4, 10 also came 4 times, right? Now what I'm trying to say, the second condition holds something like this, that if you have multiple elements, then all elements should not be should not be, their count should not be equal to maxi, right? You can have n minus 1 elements which can be of maxi, and rest one element should be at least different, right? Different, we will talk about it, but you should understand that all elements should not be the maxi, right? Now if you look closely to the problem statement, you have only two choices, right? What are the choices? Before running to the choices, if you look at the time constraints of the problem, the time constraints given was 1 in 3, right? So we can write a solution which is big O of n square or big O of n square log n. We can go till that very point, right? Anything better than that will definitely get accepted, but you need to go till that point. We can go till that point, right? All right. So what I'm trying to say now is we will always have two choices, right? What are the two choices? Let's talk about it, right? Let's say the number of distinct element was equal to 1, right? How can we find that? We can easily find that, right? I will tell you how. But if the number of distinct element was equal to 1, let's say we had 555 as our example, right? Then simply you can say the length, or when whatever the subarray length is valid. Length is valid. It doesn't need to be odd, even, anything, right? There is no talk about maximum count, what is the maximum count on all of those. Directly you can say the subarray size, whatever the subarray size is, that will be your answer, right? If my distinct is greater than 1, that is a beautiful case where we need to talk about it, where the distinct is greater than 1. Let's talk about it in detail, because that is the crux of the problem, right? So, what I'm trying to say, when the distinct is greater than 1, how will you solve it? Right? How did I solve it? How did I build an intuition for the problem? Let me tell you that. Right? So, what I need is, at every time, I need a map, right? I need a map which stores my count of element, right? That which element came how many times, right? Count of elements. Don't, if you don't understand, be a bit patient. I will do a dry run completely so that you can understand, then only I will move to the code, right? So be a bit patient. If you like it, please do subscribe as well, right? Yeah. So what I'm trying to say is, map of int comma int will store the count of elements, right? And map of int comma int, there will be one more map. What is the use of one more map? That map will store the count of maxis. What do I mean by this? You will understand in a moment, right? Just hold a bit, be a bit patient, right? So what I'm trying to say now is, let's take the first case, right? This was the first case, right? And the subarray which was valued to us was 21233, right? 213 21 233, right? 21233, right? This was my array, right? What I'm trying to say is, your first map, that is element, right? Count of element, right? Now I'm writing as cnt of elements, right? Count of element will take this 2 and mark this as +1, right? So this becomes 1, right? Let me, yeah, yes, this looks a bit clearer to you. So what I'm trying to say is, mark this as 1, right? Understand it, right? So as soon as you see a first element which came first time, what you can say, that this is a distinct element, right? We are talking about this subarray only. I want to prove to you why this solution is working for our side, right? We will see why it will also work for, means, the rest of the cases. But this was a valid subarray, right? So I need to show you how this subarray is valid in this case, right? So distinct becomes 1, right? All right. Now maxi is how many time, what is the maximum till now an element came. 1 is the maximum number time an element came, so you will update your maxi by 1, right? Okay. And you will also say that count of maxis, right, that will have how many times the maximum came. Maximum is 1, and 1 came only once, right? So you will say count of maxi of 1 becomes 1, right? Okay. Now, before we continue this diagram, please look at one more thing. What I need to prove to you is at this place. Let's say, uh, let's say my element was maxi, right? That an element came maxi number of times, right? If we have multiple elements, what is the number of times the other element should come? The number of times the other element should come is equal to maxi by 2 or maxi, any one of these, right? Is this point clear to you? Let's say if my maxi was 4, right? So the other number maximum number of time an element came was 4, means let's say 100 came 4 times, right? 100 4 times, right? So what I'm trying to say is the other number which can come, let's say if we had 200, so 200 can come either 2 times or 4 times, right? It cannot go beyond 2 and it cannot be less than 2. It cannot be 4, it can't go beyond 4 because that is the maximum number of times, definitely. But it can't be anything except for 2 and 4. Are you getting my point? Yes or no? So what I'm trying to say is if maxi is 4, then the other number of times that an element can be definitely maxi by 2 only. Yes or no? Yes. So now let's look at this place, right? Now I guess we can continue to this point if you are comfortable till this point, right? Now when you went to this element, you said count elements of 1 becomes 1, and this is also 1, so distinct becomes 2. Now you have two distinct elements. Yes, what does this hold true? Yeah, you have two elements, right? So you will say, okay, my distinct is working properly. What is my maxi? My maxi is still 1, but this element was a different one. How did we know that? We will check that as well, right? As of now you will say, okay, count of maxi becomes 2, right? Or count of maxi of 1 becomes 2. Yes or no? I hope you are making sense. Yes. Do you tell me one thing? Is this subarray 2 comma 1 a valid subarray? Yes or no? I hope you are telling no from your end, because 2 came once, 1 also came once, distinct number of elements are 2, and this is not a valid one. Yes or no? I hope I have explained you why this is not a correct subarray, balanced frequency balanced subarray, right? Okay. Now what I'm trying to say to you is you move to the next element 2, right? Be more focused now. When you went to 3, you see count of element of 2 became 2. Wow, this value changed. If this value changed, can you tell me one thing? One thing, just one thing what I want from you is how will the count of maxi change? Because count of maxi of 1 was 2. What does that mean? That means that count of maxi was storing how many times the maximum value came. But as soon as this 2 became 2 from 1, this should also update. Yes or no? Am I making sense to you? If not, let me, if someone is like saying the video is very slow, why are you going slow? Because I want you to understand what are we trying to do, right? When I came to this point that count of 2 became 2 means its value changed, then I definitely know that at some point count of this value, count of maxis should also update. What do I mean? See, initially the count of 2 was 1, right? Initially, right? And fortunately or unfortunately, that was our maxi. Yes or no? If that was our maxi and we are updating that value, then I should update this as well. What do I mean? That count of maxi of 1 1 means how many times 1 came, right? In my subarray, how many elements were 1, right? This value should update, and now initially it was 2 and 2 has left that value, means I guess I'm not making it more difficult for you to understand. Initially 2 was once, right? Now 2 is twice, right? 2 times, right? So initial value was 1. This 1 should be updated, right? And where were you storing that value? You were storing that value in count of maxi. So count of maxi should be whatever the value it has minus 1. Why do we are doing minus 1? Because 2 is not now 1 times, it is twice. So that is the reason we are doing count of maxi minus minus, right? Now count of maxi of 1 becomes 1, right? Now if you look at the count of elements, right? Count of elements of 2 became 2, right? Because 2 is twice, and maxi will also get updated by 2. Maxi becomes 2, right? Now what you will do, you will say count of maxi of 2 is 1. Yes or no? Because 2 came twice, and that is only one element is there that is coming twice. Yes or no? What do I mean? Count of maxi of 2 means how many elements are there that is coming 2 times. One element is coming 2 times. Yes or no? If yes, we can proceed further. Now, let's go to the next element as well, right? We will see what are the conditions for the array to be valid. Next element is 3, right? So you will say count of 3 becomes 1, maxi is still 2, right? And count of this element 3, count of maxis, right? Maxi of 3 is 1, right? Means maxi of 1 becomes plus plus. Yes or no? What do I mean by count of maxi? If you are having any doubt, this count of maxi represents how many times the count x appeared till now. Yes or no? Yes. So at this point count of 1 became 2, right? All right. Let me reduce this. Yeah. So if you look till now, the subarray, what is the subarray till now? The subarray is 2 1 2 3, right? Is this subarray valid or no? You will say yes, this is valid because 2 is twice and 1 is 1. 1 and 3 are ones that are multiple of, that are the factor of 2, right? Or you can say if you multiply this 1 twice, count of 1 twice, or you multiply count of 3 twice, you will reach how many times 2's are there, right? Last subarray comes 3, right? And count of 3 becomes 2, right? Maxi is 2. You are going with me, I hope. And count of maxis of 2 becomes 2. Yes or no? 2 and 3 are the two elements which are coming twice, right? Now what I'm trying to say is, what are the conditions for you? The first condition was distinct value. I'm not considering that at this very moment. How will you know that this subarray 21233 is a valid subarray? How will you say that? It is very simple, right? You will say if my count of maxis of the current value count, let's call the current value count as count, right? So I'm saying that count of maxi of count modulo 2, if it's equal to 0, the first condition, right? And what I hope this count is clear. Let's say we are standing at 3, so count is equal to count of elements of 3, right? I hope this is clear to you. If you are having doubt, drop in the comments. I will be ready to help you out, right? So if count of maxi modulo 2 is equal to 0, see, if the element came thrice, then no element if you have 1, right? 1 multiplied by 2 becomes 2, and 2 multiplied 2 becomes 4, right? So no element can be become twice of that element, right? You can't reach 3 any given day. So the count of maxi of count modulo 2 should be 0, the first condition, right? The second condition is and distinct is greater than 0, greater than 1, means you have two distinct elements. Okay, and let's say what I'm trying to say is very important at this point. This point is count of maxi of maximum whatever we had till now plus count of maxi by 2, whatever the maxi by 2 value is. If those two values becomes the count of distinct, then that is a valid subarray. What do we mean by this and how this thing came suddenly? I will make that understand as well. A detailed solution, right? I don't want to like jump to the solution directly. So let's go in the detail, right? Let's say we had 1, 2, 2, 3, 3, right? This was a subarray which was valid, right? So what I'm trying to say is count of maxi. What is the count of maxi? Count of maxi is 2. Count of 2 is 2, and count of 1, which was once that array came, was 1, right? Count of maxi of 1. Count of maxi of 1, count of maxi of 2, and count of maxi of 1, right? So what I'm trying to say is if count of maxi of 2 means how many times 2 came in that subarray, how many times an element came twice in that subarray, that should be a better English, right? How many times the elements came x number of time in subarray, right? This is represented by this, right? So if you look at this, it is 2 because 3 came twice, 2 also came twice, so that is the reason why it is 2. And count of maxi of 1 means how many times an element 1 came, it came once, right? So if you look how many distinct elements are there, that is 3, and sum of these two is also 3. That means this conditions get satisfied while you are solving this, yes or no, right? So these are the three conditions that you need to take care of. If these three conditions hold, then you can say length will be equal to j minus I plus 1, right? And if distinct is equal to 1, that means only one distinct element we have till now, then in that case length is always equal to j minus I plus 1, right? Yes or no? So this is the whole crux of the problem, right? Now let's see the solution, right? Really sorry for this. Yeah. So um, what we are trying to do is we will be running two for loops, right? This problem was a bit clumsy one, right? Pardon me if I the problem, the things got repetitive in middle, right? So pardon me for that, right? Do support if it was helpful for you, right? So now what, let's see. Yeah. So uh, wait a second, let me zoom this one. Yeah. So we are traversing on all the possible subarrays, right? We are having a count of elements and count of maxis as we had in the dry run, right? We have a distinct, we have a maximum frequency as well. We are traversing from I index to nth index. Value is nums of j. If count of element is greater than 0, then we will do maxis of count of element of val minus minus. I hope this part is clear to you why we have done this. Else, this is the very first element, so you do a distinct plus plus, right? After this, you say count of element of val plus plus, right? Int count equals to how many times this element came, and you update your count of maxis by count plus plus, right? I hope this is also clear to you. We have discussed this in detail, right? If not, please rewind the video, watch this, right? Because I have taken my whole energy to explain that part, right? And max frequency will be maximum of the values till now, right? Now what I'm trying to say is if max frequency is even, first condition. Second condition is max count of maxis of max frequency plus count of maxis of max frequency by 2. If that value is equal to distinct, and count maxes of max frequency by 2 is at least 1, then we can say length is this, right? And if my distinct is equal to this, then again the length is valid one, that all elements are same, right? We will update our maxi length in both the cases and ultimately return this, right? So I hope the statement or the approach was clear to you. If it was helpful, do give a like, do subscribe, right? And if not, tell me where the points we can improve. We will help to improve as well. And there's a Discord channel, you can definitely join that as well. Thanks for watching. Please do subscribe, it helps a lot. Thanks for watching.